yeah, like I said, we'll start at 5 after, every week, or I guess technically 35 after. Any questions, just before I even get started here? I know we're gonna be, as I said last week, we're gonna talk about lab submissions and stuff like that today. But anything pressing that, that's bothering anybody? Everybody good for right now? Okay. Yeah, we're going to get that today. Speaker is set. So that people are not hearing. I'm hearing you. Nobody else is. Bear with me.
Mr. Panzica, I can't access to the network introduction because it's not available.
You cannot use your own credentials to log into the PCs in this room. You have to use the student ID that's on that piece of paper right there.
How do I do that?
Just exactly what it says on the piece of paper right there.
Can you show me more?
Log out.
Log in?
No. Log out of the computer.
Oh.
So exit out.
Here?
Yeah. Okay. Exit the computer. Go to Windows. Power. Restart.
Okay.
What?
Alright, I meant to say sign out, but.
Oh, okay.
Alright.
Was somebody else logged in? Is that,
No, he logged into the as his own onto the
using your own user ID?
Yes.
Successfully logged in?
Oh, I don't know.
Huh.
Only on the Cisco website, but not only using this, actually.
Well, if you were logged in, then you're good. That's all you needed, was the Cisco website.
Yeah.
That's where I am right now, on the Cisco website. So, does anybody not have access to Networking Academy? Everybody's logged into Networking Academy? Okay. Has everybody downloaded Packet Tracer? Okay. So nobody's missing Packet Tracer. Is there anybody that has not yet started the Getting Started with Packet Tracer course in Networking Academy? Or do you need me to show you where that is?
Now what?
I will. So if you go to Cisco Networking Academy, and you go to Explore, Cisco Packet Tracer, and click on that, and there it is right there, Getting Started with Cisco Packet Tracer. You click on it, and then for me, it says resume course because I've already clicked on this a bazillion times, but you will just click get started, and it will add it to your My Learning tab. Okay? It's a simple 2-hour course that takes you through Packet Tracer, and if you don't do it, have fun, because there are a lot of labs that are all focused on Packet Tracer, so you need to know how to do Packet Tracer. Okay. So yeah, go ahead this week, finish off that getting started with Cisco Packet Tracer. You can go to My Learning to see which courses you have. Notice I got a couple that I've been logged into in the past. There it is. Getting started with Cisco Packet Tracer is one of them, right? And I got a Python course that's plugged in there. Yours should show so if you don't have that, then you haven't done the enrollment link properly. Okay? I've still received questions about the book.
Hello, everyone.
I made it very clear last week. You technically don't need a book because you already have the
Cisco
book.
Packet Tracer for all of your network configurations and for any scenarios you could possibly imagine and build.
I'm going to go to my classes because I'm teaching it. Yours will be in your learning, My Learning section. And this is the book.
And
This is the book. Here's module 1, module 2, module 3, and so on. That is the book.
Mr. Pinzeski,
But-
how do you?
Bear with me. Bear with me. That is the book. But my suggestion is that you buy the book if you intend to get the certification, because at the end of this semester, you are going to lose access to this electronic version of the book. Okay? You had a question?
How do you see our progress on this?
It shows you on the right-hand side when you're going through. So I'm going to go to module 1 today. And these little bubbles right here show you your progress. So, why should I take this module? Yada, yada, yada. What are we going to learn? We're going to learn all this stuff, and so on. Notice how it's showing me check marks on the left-hand side, showing my progress. Okay? All right. We're going to go through 2 chapters today. We're going to do so fairly quickly because, in the immortal words of Tank in the Matrix, this first module is major boring stuff. So we're going to move quickly through module 1 and actually get to the more interesting stuff. Most of module 1 is just straightforward reading. You're going to learn some terminology. We're going to talk about networks affect our lives. Yeah, no kidding, right? This phone right here, our smartphone, our smartphone connects to lots of different networks, right? Lots of different networks. Let's count them. First thing, this thing that I have in my ear, right? Bluetooth. Network number 1. That's radio number 1 in this phone. Okay? That thing in the ceiling, that's an access point. This white thing right here. This access point provides Wi-Fi access to my smartphone when I log in with my GTC credentials, right? That's network number 2. Network number 3 when my phone rings, right? Cell service. So, right off the bat, 3 totally different networks from this one device. Okay? What other types of networks do we have? How many people are iPhone users? Come on, raise them up. How many people are iPhone users? Usually it's a lot more than that. Wow, okay. All right, so you guys use Apple Pay, right? I use Google Wallet. We tap to pay, right? Anybody remember what that network type is called? NFC, Near Field Communications. Totally different network type. So that's 4 different networks in this one device, right? So do networks affect our lives? Heck yeah, every single day, right? The OG network, global wide area network, we call it WAN. A WAN is a wide area network. Global network is pretty much as wide as you get, right? The OG wide area network is the public switch telephone network, PSTN we call it, the telephone network. To participate on a network, you need an address, right? Depending on what protocol that is, that address has different forms, right? On the public switch telephone network, that address is your phone number, right? In the US, we have a country code that is +1, right? That's our country code. Different countries have different country codes. So the original wide area network was the public switched telephone network, where you could pick up a phone and dial the address of some other device, somebody else's telephone, right? In England, or Timbuktu, or China, or wherever, as long as you had their phone number, you could dial their address. That was their address. Their address was their telephone number. Yes.
What's today's lesson about?
We're getting there. It's about all this. This is what this is what today's lesson is about. This is what we're going through in module 1. Okay?
Types of networks and links.
All of this. Networks affect our lives. That's what I just talked about.
Right.
Okay?
Which was last week?
This is this week.
Oh, right.
All right. So,
And
I lost track.
how are we going to get the labs done today?
We're gonna get this. All right. So you get the point. Networks affect our lives, right? Network components. Let's just jump there. We have these things called hosts. Hosts is basically just a device on the network. You can call it whatever you want to. A node is another name that we use for stuff that hangs on a network, all right? Could be my phone, could be the PC in front of you, whatever. Peer-to-peer is an example of, an example of peer-to-peer networking is me sharing an image file with you, just coming up close with our phones. We tap our phones together, share an image file. That is peer-to-peer communications. It's just direct from my device to your device, and I don't need anybody else to help me with that communications, right? The other type of communications on a network is client-server, where the server is like www.google.com because I'm searching for something like, I don't know, a 2-inch solvent weld union for the landscape feature that I'm building this weekend, right? That is a web server sitting on a network, and my phone is a client on the network that is communicating with that server. So it's client-server communications. A server usually sits on a high bandwidth network that we reach out to get something from, like a web server, for instance, okay? Maybe it's a file server, maybe we wanna go get, we're storing our pictures in Apple's iCloud, for instance, or my Google my OneDrive for school, right? Any of those are servers that are sitting out there as a resource on the network, and that as a client, I'm gonna connect to, okay, to get something done.
Right.
So that's client server. End devices hang on a network, right? Local area network, LAN. This is a LAN right here. We got 30 PCs sitting on a network. These things are all wired to a switch sitting in that closet right there across from the elevator. That's our local area network. Now is the entire campus is actually a LAN. We've got a whole bunch of buildings connected together, right? Still a local area network. They have other terms like MAN, metropolitan area network, which is maybe more like a citywide network, okay? Metropolitan area network. Don't really use that term too often. Yes?
I thought it was like LAN.
WAN, as far as Cisco is concerned, WAN is beyond the immediate geographical area. So outside the realm of, let's say, the city that you're in. So it's intercity, right? So, like for instance, the WAN in Gwinnett Tech's, from Gwinnett Tech's perspective, is here, Lawrenceville, and North Fulton, Alpharetta campus, right? That's a WAN connection. We have the campuses connected, long haul fiber. Do we own that fiber? No, we lease that fiber. And that's the difference between, that differentiates LAN and MAN or WAN. So metropolitan area networks, usually we're also renting service, right? Leasing service from a service provider like AT&T or Comcast or whoever, right? Can be anybody. But a service provider, we're renting the connectivity from, right? Same with WAN. WAN could be satellite network, right? Could be you're hooked up with Starlink or HughesNet or any of these other satellite providers, right? So it could be any kind of WAN technology. This is the inner network is what resides between, is usually offered by the service provider, so we're renting that connectivity. And it connects the two LANs, like for instance, here in Lawrenceville and over in Alpharetta. There's stuff that we use to build these networks. We call them intermediary devices, okay? Wireless routers, LAN switches, multi-layer switches, basically just a switch that can also do routing functions. There's firewalls and VPN concentrators, and there's all kinds of stuff. But for the most part, kind of the nuts and bolts, the top layer, right? The wireless routers, right? Because wireless connectivity is way prevalent. Right? We use wireless a ridiculous amount every day. LAN switching is the infrastructure that connects that wireless device into the infrastructure, the hardwired infrastructure, so that we can make things work. And the routers do the routing between subnets. Subnets is a term that you will learn very soon. Okay.
So what do we learn about today?
What's that?
What are we learning about today?
We're going through it right now. We're going through it right now. Network components.
Network components.
Yep.
Carry on.
Network media. There are various types of network connectivity, obviously, clearly, right? We've all heard about fiber to the home, right? I wish, not in my neighborhood. I'm stuck with Comcast cable service, or Spectrum, or whoever you, Xfinity. It's all Comcast, right? That runs on coax cable. It's copper cable, one center conductor that I share with everybody in my neighborhood. All right, it's shared, what we call shared media. We'll talk about that someday. Okay. There's fiber. Fiber is nice because you're not sharing it with anybody. It's a point-to-point type connectivity, and it's super high bandwidth, and it's very reliable. Twisted pair. You see two cables hanging out the back of these PCs. That's copper. It has 4 pairs of wires in it. We also call it UTP, shielded twisted pair. Sometimes in harsh industrial type environments, we'll use shielded twisted pair. It just, basically it's the same thing with a foil wrap around it, to keep out interference from electronic signals and whatnot. Right? But the point is, there's lots of different media. Some of it we can't even see, right? We still call it media, even though it's radio frequency. That thing on the ceiling that's feeding our smartphone with Wi-Fi, we can't see it, we can't touch it, but we still call it media, okay? We actually still call it physical media, even though it isn't physical. I mean, it kind of is, right? It's got a waveform. It has energy. When we're building these networks, clearly we want to diagram the networks, and there's a couple of different ways we diagram them. A logical and a physical. Right? If I want to describe the electronic equipment that is sitting in that closet across the hall, I might depict the actual racks that the equipment is sitting in. In fact, the equipment that is in the lab room right next to us here, I diagrammed all the stuff that is in each of one of those racks. Okay. Physical. Where is it? What slot is it in a rack? That kind of thing. Right? We have actual name for the room. This web server is in rack 2, shelf 1, and so on. What is it connected to? Notice that we're showing connectivity between devices. Here's a switch, here's a router, and so on. A logical topology diagram is a little different. We don't care so much as to where the device resides in a room, for instance, or in a building, but what network is it connected to? These devices could actually be in 3 different buildings. The web server, the email server, the file server, they could each be in 3 totally different buildings. As far as this diagram is concerned, though, they are in the same network, so we draw them together in this network that we call 192.168.10.0. Okay? That is an IPv4 address, network address, representing this group of devices. We talked about LANs and MANs and WANs and stuff like that. We have different types of, I'm gonna skip the internet connections. You guys, again, you notice that I am not, for this particular chapter, I'm really skipping. right? You guys need to make sure that you read front cover to back cover. Right? Front cover to back cover. There are multiple types of internet connections, business and residential. We talked a little bit about that. Right now, I'm stuck with Comcast for my internet at home. Some of you guys might have access to either Xfinity's fiber product or AT&T's fiber product. Lucky you. Some of us might be in a rural area where all we have access to is a wireless rural provider. Right, up towards Helen and all those places up north, you don't have fiber running down the highway. When we're building networks, these 4 bullets here are our primary concerns. How do we build fault tolerance? How do we handle scalability? This term quality of service, or QoS, is one that is particularly important now because so much of what we do on the networks today is mixed. And by mixed, another term for that is converged, where we're mixing data and video and audio all on the same network. And all of these things have very different requirements. Data can wait around a while, right? Relatively speaking, on a network, it can handle delays. Voice, on the other hand, if we're doing, for instance, voice over IP, or if I've turned on Wi-Fi phone service, right? Talking over Wi-Fi as opposed to over the cellular network. Now I'm depending on how effective is my voice traffic being routed on the Wi-Fi network that I'm connected to. All right, quality of service is a means by which we can dial in our networks as network administrators to ensure that voice traffic has highest priority. So it doesn't get slowed down by great big file transfers that might be going on elsewhere on the network, right? Voice has very, very high sensitivity to delays and dropped traffic. So it needs to be given prioritization. That's what quality of service gives us. And of course, we need to secure a network, right? That's the 4th bullet. We need to address security in the network. Let's talk about chapter 2. Cisco pioneered routing and switching, really, to be honest. They were back in the early 80s, there were many network equipment providers, but Cisco really did it right. And they did so by coming up with, Cisco, believe it or not, considers themselves a software company. Yeah, they sell a boatload of hardware, no doubt about it, but they consider themselves a software company. And that has everything to do with this little picture right here, right? The hardware sits in the middle, and then we have a kernel operating system and a shell with which we interact as users. And it is Cisco's iOS. They were using iOS long before Steve Jobs was. Cisco's iOS is the brains of the box. okay? It is what we interact with in command line interface mode. Right? When we connect to a terminal using a terminal emulation program to a router or a switch, it is character-based, just like this, right? Just like this example here. In this case, we're connected to a Linux box, it looks like. We're logged into this thing called SecOps, it looks like, and our username is analyst. And we're asking it to do a listing of the current drive that we're on. And that's what we get as output, right? That's an example from a Linux box, right? Cisco is not much, oh yes, question?
You're essentially saying that that terminal, the way it looks like, that was invented by Cisco?
Not the terminal itself, but the notion of a management interface that is modular to control internetworking devices.
That's like the concept of it itself.
The concept of text-based configuration, scripting, quote unquote, scripting language. It is in a scripting language, so I want to be careful about using that term. But the notion of having that shell available and creating a command structure that is modular for the control of an internetworking device is what Cisco pioneered. And they did it so well that everybody duplicated it. So you learn how to, I think I may have said this in the first week, you learn how to program Cisco networking devices, you effectively learn how to program everybody else's gear as well, because it's not much different. All right, there will be differences, no doubt about it. They don't want to get sued by Cisco, but make no mistake, Cisco did it right and everybody copied it. And that is the command line interface. Why is it not GUI? You might say, why don't we do the Windows type thing, right? Because doing this, providing a user a nice pretty graphical interface, eats up a lot of resources. Resources that we could be using to run the network device instead, right? We need something that's clean, simple, doesn't consume a lot of CPU, doesn't consume a lot of memory on the internetworking device, and so we use command line interface, right? Obviously, the purpose of that OS is to drive the hardware, right? And provide us a mechanism to where we can connect and manipulate the device, control the device. By the way, every device has its own image, its own software image that it runs, right? It kind of makes sense, right? Different devices need different features, right? Supported in their software. So a router, a switch, different routers and switches. If you look at this example here, we have a Catalyst 2960 24 TCL switch, right? And we're on the software download page, on Cisco's software download page. Notice the name of the image right here. You see it? Or see where it says LAN base? Right here. It says C2960 LAN base K9-MZ blah 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 blah, right? So the image file name itself actually tells you what device it's for. It also includes some version information. So the numbers following the -MZ is 122-55 SE12. Notice that matches the release number up here. Does that help a little? It's a little small. 12255 SE12 is the version of the software. Okay? So that's where that file information, that file name comes from. Cisco 2960, C2960. LAN base is the feature set, so basic LAN feature set. And then the version. We want to connect to a device. We basically have 3 different methods. Technically, we have 2 different methods. We can either directly plug into a device, we call it console connection, or we can reach out over the network. If we reach out over the network, there's a couple different protocols we can use. We can use SSH, secure shell. It's secure, called secure, because it uses cryptography, to secure the communications. Telnet we don't use anymore because it's not secure. Everything is transmitted in the clear. So if you type in a password, and somebody has access to your network and can capture the packet as it transmits across the network, they can capture that password. It's in the clear. It's wide open. One of the things that you'll do is download Wireshark. Wireshark is a product that is free, that is absolutely incredible in that it can show you what's going on a network. You can actually sniff a network. You can watch packets as they traverse the network. It's an amazing tool. But you look at a telnet packet, somebody type in a password, you can see that password. SSH, not so much, right? So telnet is only used, like in my case, when you're using equipment that is so old in your lab that it no longer supports the modern cryptography protocols that are in use nowadays. And so therefore I can't turn on secure shell on many pieces of equipment that are in our lab because some of our lab equipment is like 25 years old. So the crypto the crypto used by your terminal emulator will not sync with the crypto images that are algorithms that are present on the gear. So I have to resort to using telnet only because that gets around that problem. But other than that, we don't use telnet. Lots of different telnet emulation, terminal emulation programs. Some of them are free. PuTTY and TerraTerm are the examples that they give here. TerraTerm, I use Secure CRT. I've been using that for a long time. It's handy because it has a tabbed environment where you can bounce between devices and whatnot, kind of like you do with your browser. But they all do the same thing. They allow you to connect remotely via either telnet or SSH to a device that you want to configure. All you need is an IP address to point it to, and you're off and running.
How do you get 2.1.2
That's it.
finished?
You didn't get it finished.
No.
That's alright. Just finish reading it later.
Yeah. Okay.
So, when we're configuring, when we connect it to a device, there are 2 basic configuration modes that we can be in. Either user exec mode, which is the first one with a greater than sign after the host name, Notice that it says switch or router and then a greater than sign. That's what we call user exec mode. You actually don't have much control at all in this mode of operation. You can do some rudimentary show commands to see what's going on the device, but other than that, you can't do anything. You can't configure the device. You have to go into privileged exec mode in order to get something done. We access privileged exec mode by entering the enable command. We'll see that shortly. But notice how the prompt changes, all right, to the pound sign. So the pound sign tells us what mode we're in when we're connected to a device to configure it. All right, so greater than sign, user exec, pound sign, privileged exec mode. I'm going to use this video to show moving between the modes. Sorry, no, I'm not. I just realized that for some reason my audio is not picking up the speakers in the room. So, if I go into configuration mode, I can tell I'm there because it says config. Alright, so the prompt always tells you where you are in the command structure. So in this case, I'm connected to a switch who actually has the default name. The default host name for a switch is switch. The default host name for a router is router, right? And I've entered the enable command to get to config mode. Now, if I want to configure a password on the console port, which is always a good thing, right? Because if I plug into a piece of equipment and there's no password on the console port, then I'm in the box and I can just start configuring things, right? So if I go into line console 0, this puts me in a position to configure the console port. And notice immediately when you hit enter, the prompt changes from switch config to switch config line mode. Right? So it shows you what mode you're in. You're in line configuration mode now. Right? If I exit, then I'm back to global configuration mode. So this is kind of the rudimentary bouncing around. Where am I in the command structure in configuring a router or a switch? If I end, no matter where I am in the command structure, it drops out of config mode, right? And I have to go back into enable mode to do something. If I'm in config mode and I type interface, because I want to configure an interface, then notice the command prompt changes to config IF. Another